welcome to this talk about knowledge graph-based chatbots. My name is Mayerhofer, and I just want to start with a little information about myself. I'm a software engineer at a company called Mayerhofer and an LLM enthusiast, and I've been working with different ways of integrating AI and LLMs with our database for a while. So Mayerhofer is a graph database company, which means that we store data in a graph as nodes and relationships, instead of like a regular relational database where you store data as tables and rows. And we have a booth here at the conference just at the entrance, so if you would like to know more about us, please come by and chat, or if you want to chat about AI or LLM, you can contact me on any of these platforms, or just come by and chat. And today, this is the agenda. I'm going to start to introduce a little bit about LLMs and how chatbots such as ChatGPT work, and then look into how we can improve these chatbots with unstructured data, and then continue to how we can improve them with structured data, and then in the end, combine these two and hopefully have a live demo. You know how that usually works, but we'll give it a shot. So let's get started. LLMs and ChatGPT. So LLMs are a kind of generative AI, which means that it's AI or a computer that generates on context. And I double-clicked. And LLMs are large language models, so they work with text, so they generate text. And that's like the backbone of how ChatGPT works. It's the backend of what generates the answers. And they are trained on a lot of data. I'm talking terabytes of terabytes, and it can be like books or just regular web pages from the internet. You just collect a huge amount of data and feed that to an AI, and it works pretty well, right? Everyone has probably tried ChatGPT. It can help you with answering questions or rate your presentation or whatever, help you write a more professional message. But there are some issues. So firstly, they have a knowledge cutoff date. So this is an image of when I earlier asked ChatGPT, when does Øredev 2023 take place? And as we can see, it can't answer it. It only has a knowledge up to January 2022. So that's not great if you want to ask about recent events. It also does what is called hallucinations, basically making up things that aren't real. And you can often sound very, very confident when it creates something. Here we have an example of a lawyer that used ChatGPT to help him create a legal brief and cited fake cases. And that's not a great look, right? So that's also an issue. You can't really trust it. And this goes hand in hand with that. It lacks information sources. ChatGPT doesn't cite its sources. It just say, this is how it is. And it also lacks domain-specific or private information. Like if you have a private database, of course, it can't know about the data in there. It's private. And if you work in a very narrow area, it probably don't have a lot of data on your specific subject, so it kind of lacks some knowledge there. And I really like this comparison with ChatGPT and a parrot. So both learns random sentences from random people, talks like a person but doesn't really understand what it's saying, occasionally speak absolute nonsense, but a parrot is a cute little bird, so clearly superior. So we should just throw out this AI thing and start over with parrots instead. No, of course not. We should try to improve it. So first we're going to take a look at how we can improve these answers and solve some of these problems with unstructured data. So something that's very common to do is to use retrieval augmented generation. And that's basically, that's basically that you provide relevant context in the prompt to the chatbot. So you give it some information that you think will help it answer the question. And this makes it so you avoid relying on the underlying facts that the LLM have been trained on. You get increased transparency since you know where the information you've provided the LLM comes from. But the answer is only as good as the context you give it. And an example of this we have right. Oh, no. Okay. An example of this we have right here, where I asked the question that who won the NBA Finals MVP in 2023? And as we know from before, it couldn't answer questions about information in 2023 because it didn't know about it. But if we start here by giving some relevant information, here we have given a headline from official NBA news of who actually won the MVP. Then we can see that ChatGPT happily answers the question and also cites sources. So it says the information is from official NBA news. So this is great, right? We solved the hallucinations. We have information sources, and it can answer questions of information it wasn't trained on. So if we want to build a chatbot that works like this, we would have a flow that looks something like this. We have a user here to the left asking a question, and then we need to have some kind of smart search that finds this relevant context that we want to pass to the LLM so it can help it answer the question. And this smart search can be connected to a knowledge base you have created. It can be private information, so you don't have to leak it to someone else. And then we retrieve those documents, send the documents together with the question to the LLM, and it can answer the question as we saw just now. So this smart search, how should it work? And the secret here is a lot of math. Sadly, like all the fun things, there's a lot of math behind it. But it's actually not that hard, so I'm going to walk you through it step by step, how it works. And we're going to start with something called a vector embedding, which is basically just a representation of some information in a vector format. So you can, like for example, you can turn an image or a text or a video into a series of numbers. And these numbers basically represent the meaning of the image or the meaning of the text. And we're going to focus on text since we're talking about chatbots. So, for example, any text can be converted into a series of numbers. It can be a word, it can be several sentences. It doesn't really matter. And the cool thing with these vector embeddings are that if you place them in vector space, here's where the math comes in. You can imagine them as a point. So here we have a three-dimensional vector space. So we would have three-dimensional vector embeddings here, but it can be longer than, it can be thousands of dimensions. And the cool thing here is that the vectors gather up in the meaning of the things. So to the left we have different animals, and to the right we have different fruits. So then if we would like to search for a question or search for something, for example here we search for kitten, we can see that cat is very close to kitten, so we get the related information. So if we would imagine having a database like this with headlines, for example, news headlines as we saw before, and if we then feed it the question of who won the NBA Finals MVP in 2023, it will probably end up close to the headlines describing who won the finals. And then we can retrieve maybe the 5 first headlines. And that's basically the whole thing, and then we just hope that it works. And it works for most things. It's slow again. Yeah, okay. Works for most things. And here's an example of an application built in this way. Here we have some pre-processing, where we basically take the PDFs, chunk them into text pieces, and save them in a database. And for example, you can use a Neo4j database. We have added vector indexes recently, so you can quickly look up this vector afterwards. And then we just have the same flow here to right. A user asks a question to a smart search. It looks up the most relevant document using this vector similarity search and feeds them to the LLM. And the LLM can answer the question. And we get some improvements by this. We avoid relying on the facts provided by the LLM. We increase transparency, since we know where the data comes from. But there's some cons. So vector similarity search doesn't always find the correct documents, especially if you have many similar documents or the same duplicated document. It can find the same information again and again and give it to the LLM, and that's not really helpful. We want to find a few most similar and hope that the answer is in one of them. But we can keep going. We can improve this with structured data as well, instead. And this also solves another problem. So there's something called multi-hop question answering. So we can, for example, think of this question. Did any of the former OpenAI employees start their own company? And this is really two questions in one, right? First, we need to find who are the former OpenAI employees, and then did any of them start their own company? If we would do this similarity search, we kind of wouldn't find out who the people are. We kind of would find out like if OpenAI employees started their own company. We could split it down into two questions using an LLM and then do a vector similarity search twice, but that's kind of a hassle and takes a long time because LLMs are very slow. So we want to try to avoid that and be able to answer this question in one go. And our solution to this problem is knowledge graphs. And knowledge graphs is just a collection of data, information represented in a graph format, basically. So Neo4j is a perfect use case for this. You just save information as a graph. And I'm just going to show you a quick little introduction here to a knowledge graph. So data start with things, and in a knowledge graph, we would have nodes representing things. So here we have two people, a city, and a pet node. And these nodes can have properties, so the people have names and birth dates. The city also has a name, the pet also has a name, but they have some other extra information as well. And then the things can relate to each other. So the people can be friends with each other, they can own a pet, they can live in a city. And this is basically a very, very small knowledge graph. And here is an example of a little bigger one, where we have Mona Lisa here in the center, and Da Vinci painted the Mona Lisa. You get the idea. You just try to represent some information in a graph. And to query this graph, we use a language called Cypher, and this is something we're going to use with the LLM. We're going to try to make the LLM generate Cypher to query our graph. So this is just a little example of how Cypher works, as you have seen it once, but it's kind of like pattern matchy. We write a match class, and we try to find a person with the name of Dan, and then we're going to find the relationship loves from Dan to some node. So basically find out who Dan loves and return that person. And this can kind of solve our multi-hop thing, because if the LLM can generate Cypher, it can generate like find Dan and then who Dan loves and what that person works at, for example, in which city the person lives. So they can generate one Cypher query that will answer one of these multi-hop questions. So if you look at our flow from before, it looks like this. We have our smart search and our knowledge base, but we're going to modify this a little bit. Instead of having a knowledge base as a vector database of different documents, we can have a knowledge graph there, and we can improve our smart search a little bit. So we have the same beginning. A person asks a question, and our smart search will try to understand that question and turn that question into a Cypher query that we think will find the information to answer the question. So instead of doing vector similarity search, we create a query, run it against our database of our knowledge graph, and then return the relevant information. And then we have the same thing. We send the question plus the relevant information from the database to the LLM and let it answer the question. So just basically extra or another step. Instead of doing similarity search, we generate a Cypher query. And I'm just going to take a sip of water. And how this Cypher generation works is quite simple, actually. We basically just ask the LLM, please generate some Cypher to answer this question. But we give it some extra information here in the beginning. This is the database schema, or just a text representation of the schema. So basically it describes which kind of nodes are in the database, which relationships are there, which nodes they go between, what kind of properties the nodes have. A little bit of information, though the LLM knows what kind of queries it can create. And then we send the question, and at the bottom here we get some Cypher generated. So here we asked, who is the CEO of Neo4j? And we get some cipher query that says to find the organization called Neo4j, find the relation has CO and return the person that are in the end of that relation. And that will find the right person, of course. So that's great. That kind of works. And this gives us some improvement over the regular use of unstructured data. We avoid relying on the underlying facts still. We also have the increased transparency from before, but we also get the benefit of answering multi-hop questions. But it requires some processing of the data, right? We need to construct our knowledge graph. We can't just send it a bunch of PDFs and make it work. There's a little bit more pre-processing. And it's not suitable for all workloads. For example, if you just wanted to summarize a few PDFs, that's, of course, not worth doing a lot of pre-processing for. But now we're going to try to benefit from both of these by combining the different data types. So we're going to use both unstructured and structured data to make it be able to answer questions of both types and being a little smarter. So we have another flow. This one is a little bit more complex in the beginning, but in the end, we still have a smart search with a knowledge graph and send the cipher query there. But we do a little extra step here in the beginning. We have two paths actually. So we send the question from the user to both an LLM and ask it to extract all entities in the question. So for example, we ask who is the CEO of Neo4j? Neo4j would be an entity, right? So we extract that entity and then we do a text search in our database and find all nodes or all entities called Neo4j and return that information as well. So we get some extra information in our smart search. We also here have at the bottom have another database called lookup cipher examples. And what it does is it's a collection of questions and cipher that answer those questions. So we do a vector similarity search between the question and just a whole bunch of different cipher queries that we know have answered previous questions. So we kind of need to build this database from the ground up for our specific use case. And what we can do then is find questions that are similar and cipher queries that are similar, that answer similar questions. So when asking who is the CEO of Neo4j, we can have a question in the database saying who is the CEO of Amazon. And then we can send that to the LLM creating the cipher query, and it will kind of understand that I just need to replace Amazon with Neo4j. This is a very similar query, and kind of help the LLM a little bit when generating cipher queries. Because since it's not created for cipher query generation, it's not the best at it, so we kind of need to give it a little push in the right direction sometimes. So that basically gives it a little bit help in creating queries, and that's the only extra processing we've done. And then we have the same thing as before, where we generate a cipher query and get the relevant information from the knowledge graph. And we can answer the question. And I'm going to show you a little demo of this. We actually created a chatbot using this approach. So this is a venture capital chatbot. So it's connected to a database with a lot of different companies and organizations, people that are CEO or chairman of these companies, and people who have invested in different companies. And we have our chatbot that can answer questions here. So we can, for example, take this question you heard a few times now. Who is the CEO of Neo4j? And it. And it takes a little while to generate. But we got there. And we can see that the CEO of Neo4j is Emil. I can zoom in a bit. And we also have a tab here that we can see the cipher generated. And it's very similar to what we saw before. It finds the organization called Neo4j and the CEO. But then we can also ask other questions. So we can ask multi-hop questions like this. How is Emil Eifram connected to Magnus Christensen? And this is a multiple question, right? We need to find Emil and then find a path to a node called Magnus. And we can see that they are connected through their roles at Neo4j, where Emil is the CEO and Magnus is a chairman at Neo4j. And we can also answer questions like, what are the latest news around companies where Emil Eifram is CEO? And I know we have asked it now before, so it kind of could understand it from the history, but this kind of requires us to do a multi-hop question or answer. It basically needs to find what companies Emil is CEO for, and then find the news about that. So let's give it a minute. So, the latest news of companies where Emil is CEO is the announcement of a product, and it kind of summarizes some news. So, this is a really cool thing with this database as well. We have both structured data in that Emil is CEO of Neo4j, but we also have different news articles in the database. So, it can find the news articles that are just unstructured data and summarize them. But it also can find structured information such as how many employees a company have, or we can ask any question really here, like what is the biggest company? And we can see what it comes up with. So in this database, the biggest company is Accenture Solutions with a revenue. Okay, so it thought that we went biggest revenue. We asked biggest. Maybe we should have asked what are the company with the most employees. So you kind of need to be very detailed with your questions as well, so you understand what you mean. But did something funny here. It only looked at these three companies. So yeah, that's maybe why I thought it was the biggest. I thought that was a little weird, but as you can see, it's not made for generating cipher, so it's not a perfect solution. But I still think this is really, really cool. Like we can ask a computer to find some information in just a database we've just provided it, right? But yeah, this is something we're working on improving. I hope that wouldn't happen, but you know, live demos. But yeah, really, really cool, I think. We can get both structured and unstructured information. We can ask basically any questions on this. And I think it really can help other people that doesn't know programming or doesn't know SQL to kind of connect with the database and get benefits of a database some developer have created. And maybe we can help companies, like their executives can use this maybe to find some information. And maybe it's easier to show people that are not developers on the benefits of using knowledge graphs and using this kind of workflow. So everyone gets benefits and not just the developers. And of course make it more accessible to everyone. And let's go back here. So to summarize, we improved the chatbots using such as ChatGPT. We made the answers more explainable since we provide what data we give the chatbot. It doesn't come up with the information from its original training. We improve responses about private data since we can connect any data source to it really, and it doesn't just know about public data. And with that, I want to say thank you for listening, and I'm happy to take some questions. I know this can be quite a lot, so if you would like to ask questions later or and just chat, you can just contact me at my email there at the top. And the repository for this demo is open source. Here's the link, or you can just Google Thomas Batanik, which has written a lot about Neo4j and AI and knowledge graphs in general. And if you want this presentation, you can just, one of my colleagues will stand at the exit and scan your badges, and you can get an email with the presentation afterwards your conference. And if you want to chat with us, we are standing at the entrance of the conference hall. And thank you so much for listening. I hope this was inspiring. And yeah, questions, I'm happy to take as well. Yes. Yes, if we have a microphone in the back, maybe that's easier, but the question was if there's any cases. I said this is not suitable for all cases, so maybe like what are those cases? I would say if you just have a lot of documents and just want to see, basically find information in those documents, it's probably better to use one of like the unstructured approach or a full text search or something. I know that in legal businesses, they often have a lot of laws. They want to see how they are connected and what they say. And that's probably a use case that's more suited to the unstructured approach because it's a lot of time to go through all the laws and create a knowledge graph from it. Cool. Any more questions? Yeah, you over there.
Is it turned on? Can you hear me? All right. I have a document about security rules in my company, and it's very extensive and completely impossible to read. My question is, I feel like I want to take that document through a process and start querying questions. Would that be a case you've seen before, or you could recognize that use of it?
Yeah, I think the first where I just talked about unstructured use case when you use vector embedded, I would say that's a use case that could work. I would say like try to split the document into pieces, maybe a few hundred characters long. And I think the consensus is that you want some overlap between them, maybe do some smarter splitting than just on 200 characters. But we've tried that and it works kind of well for just answering questions about it. When you need to have connections between the documents, so if a document refers to something several pages down in a document, then it might start getting worth constructing a knowledge graph of the chunks and then how they relate to each other. So you can find some smarter connections between them instead of just the text from top to bottom.
Okay, thank you.
Thank you. Any more questions? No? Cool. Thanks for chatting or coming. But if you want to come and chat with me, I will be at the Neo4j booth. Happy to talk about AI or anything graph related, really. And again, thank you very much.